So to solve rational equations, we're going to use, in fact, many of the same methods that we use to add or subtract rationals, but we do deviate a little bit because now we are dealing with equations that we can solve for x. So we will get straight into it. First thing we need to do is create a common denominator. Now I'm going to write out the equation again with a little bit of space in between, only to make the writing the common denominator look a little bit nicer. Second thing I'm going to do is take this 1, make it 1 over 1, which will make it easier when we do the common denominator. Looking at that, looking at coefficients for the common denominator, we have 4 and 1, so we'll need 4. Variables, we have x, so we'll need x, common denominator of 4x. With x over 4, if we multiply top and bottom by x, we'll make our common denominator of 4x. With 7 over x, if we multiply top and bottom by 4, we'll create that common denominator. And with 1 over 1, if we multiply top and bottom by 4x, we'll get the common denominator. Multiplying this out, we get x squared over 4x minus 28 over 4x equals 4x over 4x. This is the point where we're going to deviate from the methods of adding and subtracting. Because we have an equation, we can multiply each and every term by the denominator. And the purpose of this is to cancel the denominators. And we do this mostly because solving equations without denominators is easier than solving equations with. Lets us rely on some methods that we've learned previously instead of having to create new ones. So what we are left with is x squared minus 28 equals 4x. This is a quadratic equation because we have x squared. When solving those, it's always best to get 0 on one side. So if we subtract 4x from both sides, we'll get x squared minus 4x minus 28 equals 0. And with solving quadratics, again, we have many methods of doing it. We could use quadratic formula. It's always foolproof. We could try completing the square. But always best to try factoring first. It's the easiest, it's the quickest. So to factor this, we would need two numbers that both multiply to negative 28 and also add to negative 4. And a set of numbers like that doesn't exist. So we will want to look at the quadratic formula for this. Remember, when dealing with quadratic formula, we need to identify coefficients. A is coefficient on x squared, that would be 1. B, coefficient on x, negative 4. C, constant, would be negative 28. Going to the quadratic formula, we have x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Which would give us x equals negative 4, which if you just want to write that as 4, go ahead, plus or minus square root of negative 4 squared minus 4 times 1 times negative 28, which is all over 2 times 1. Working this out, we do get 4 plus or minus the square root of 16 plus 112. because negative 4 times 1 times negative 28 is positive 112. Divide that by 2. Keep going, we get x equals plus or minus 4 plus or minus the square root of 128 over 2, excuse me, not 4. We can do the square root of 128. Square root of 128 is roughly 11.3. Once we get here, we take it, we split it, so we get x equals 4 plus 11.3 over 2, and x equals 4 minus 11.3 over 2. So on the left, we get x equals 15.3 over 2. Divide that out, we get x equals 7.65. On the right, 4 minus 11.3 is negative 7.3 over 2. Missed the equal sign, and x equals negative 7.3 over 2. Dividing that out gives us x equals negative 3.65.